Good morning. Happy rainy Friday to you. It's a great Blacksburg Friday. We love it. So glad you all are here. My name is Phyllis Newbill. I'm the Associate Director of Educational Networks in the Center for Educational Networks and Impacts within ICAT. I'm so glad you all are here. A couple of housekeeping things before we get started today. First, we are filming in 360 this morning. And filming, I know it's not the right word. We're video recording in 360 this morning, so streaming even right this minute out onto the interwebs. So your image will exist now and forever on the internet, so behave yourselves. Good morning to those of you who are joining us online. I'm so glad you're here. Please be sure to sign in. We'll run the sign-in clipboard around one more time. It was out by the donuts if you missed it. We do have donuts, so I hope you'll have some of those on the way out. You can't eat them in here. But you do need to sign in because that's how we justify donuts, which is the most important part, and coffee. Thanks, Tom and Melissa. If you have questions this morning, just wait for me to get to you with the mic if you're in the room. And if you're online, please use the questions link, and we'll get those through that form, and we'll ask them here. If you are looking for PDN credit, if you're a faculty member at Virginia Tech and that's helpful to you, just make sure you just check in with me and make sure we get you checked in and get your 100% for that. Announcements this morning, ICAT Day is coming up May 1st. That's a day we celebrate all things ICAT, all kinds of projects and exciting ways that we combine science, engineering, arts, and design. If you have a project to share with us, those are due March 17th, so that's after spring break. And finally, I get to introduce this team. So David Franisich is part of our ICAT team, and each winter we've been doing a wintermester course about this room that we're in. We're in the Cube today, and I'm going to let David talk about that because I will probably mess that up. So David Franisich and team.
This one. Okay, I stole Phyllis's mic. If you hear two mics, then we'll fix that. Good morning. Thank you all so much for coming out on this uber gross Friday morning. I was really worried that nobody was going to show up because, heck, if I wanted to leave the house this morning. But yes, thank you again. So this morning I'm going to talk about the class we had over the winter session, partnered with the College of Architecture, Arts, and Design to put that on. But before I dig into it, I'm going to let a lovely video play that was made by Ray Meese just to give you all some wonderful context for what we're going to be talking about. So hopefully that gives you a nice little primer, gets you excited about what I'm going to talk about here, gives you some context. So Intro to Immersive Multimedia was a class that was offered through the College of Architecture, Arts, and Design. So as all of you, or most of you probably know, ICAT is not an academic unit at the university. We cannot just have a class. We can do workshops and things like that, but we cannot just have a class all of our own volition for academic credit. So we have to have partner with an academic unit to do this. So just want to mention this at the very beginning. We offered this through the College of Architecture, Arts, and Design, which was a lovely fit for the class. It is the most recent iteration of a class that has been historically held here in the Cube to teach students and whoever wants to take it the systems that are in here and in Perform Studio. Why do we have this class? We have this class because this space, ooh, we're getting some lovely hums somewhere. This space and Perform Studio are, let's say, unique, almost unique in the world. They are very rare spaces. The systems in these spaces, the kinds of immersive things that you can do in these spaces with audio, video, motion capture, and whatever else your brain can come up with are amazing. And people that have access to spaces are normally funded research projects, Moss Arts Center performances, professional artists who are coming for residencies. It's not very often that undergraduate students have time, space, and permission in here to do whatever the heck they want and to learn how to use these things that they probably wouldn't learn how to use otherwise. And then a little bit of expert guidance too along the way to get them where they need to go. So for those of you who aren't aware, the winter session is an intense 2-week semester. Classes are 4 hours a day for 2 weeks straight. So you get 3 credits worth of classes in a very condensed time. And it's a wonderful format for this type of class because everything is so hands-on. You need to really spend a lot of time with the systems. You really need to dig in, spend hours and hours on maybe just one little piece of a thing that you can't really do if you're only 50 minutes a couple times a week over the course of a whole semester. So this is the entire class of students right there. A couple of them are here today. We had 8 students from across 5 majors, which was wonderful. We had represented architecture, creative technologies, industrial and systems engineering, studio art, and general engineering. So in addition to letting students access this space, we also want cross-disciplinary interaction between students. This is something that students don't often get either. So that is the secondary motive of having this class. So we have a class in here. What does that mean? What do you do when you're in here? Do you have a test on how to number all the speakers and get audio to a specific place in the cube, or motion track Ben dancing around at the end of the 2 weeks, as he would love to do? No, we're going to keep it really simple. You're going to use at least 2 of the systems in here, 2 of the major systems that are available in here, which are the cyclorama, which is not in here right now, but you saw it on the video. Spatial audio / the high density loudspeaker array, which is the speakers that you see all around us. Motion capture system. There are 24 motion capture cameras in this space that we can use to track motion either in real time, or we can record motion and then play it back later. And then also a new system that we're implementing in the cube this semester, which includes the ability to project onto the floor. So this is a really exciting new development that we have here at ICAT. We have some new projectors that are allowing us to do some really cool things. And so these are group projects. They were going to be required to use 2 of these systems, at least 2 in their project, and then have fun. And that's, I mean, this is an oversimplification, of course, of the class, but this is really the 2 main parameters of what we were working with. We had 3 teams. And we have a few student representatives here today. and I'm going to bring them up to talk about it. Our first team was Team Mosh Pit with Alex, Anderson, and Hunter. And I'll just preface it a little bit. They used 3 of the systems. They used the cyclorama, they used the HDLA, and they also projected onto the floor. They also used some other systems that aren't specific to the cube, but I'm going to let Hunter come up and talk about that. Come on up.
Thank you so much, David. Hey everyone, I'm Hunter Irving. I'm a software engineer in the Advanced Research Computing Department. And actually, the way I came to find out about this class was kind of at the last minute, just a few days before the class started. I ran into Ben Knapp at Greens. He told me this class was happening, and I was like, I gotta get in there. So I did some emails with Tanner and David, and they were like, this is what you need to do to get into this class. I did it. It worked out. So I guess we can talk about what this piece is. So this is called Mosh Pit. And essentially we used the cyclorama and the floor projection and an Xbox Connect to track where people are in the space. And when people step into one of these 3 circles that are projected on the floor, basically different visuals will appear on the cyclorama. So in this way, you can kind of create this glitchy mess of sampled video and audio that we found on archive sites, and you can really control it with your body. So these 3 zones, basically the more matter that's detected in these 3 spaces, the faster the audio and video will play and the louder it'll become. So by kind of leaning in or leaning out, people can control the audio and the video themselves. And I guess what we were going for is just sort of an abstract, glitchy soup. There on the left, we're sampling an old claymation. We've got some old Disney cartoons in the mix. And we also have just some scripts that I wrote myself to kind of create these weird visuals. But we used a program called Touch Designer, which is, it's a programming language, but it's a visual programming language where you arrange nodes to basically write a computer program. So basically, we didn't really have to write any computer code to make this installation happen. Yeah, and as you can see, people are walking in and out of these things, and you kind of also have this ghostly after image, and that's all done by the Xbox Connect. Actually, it's not an Xbox Connect anymore. It's a new thing. But that sensor right there in the middle. At one point, we were actually thinking about using a Raspberry Pi computer and a Raspberry Pi webcam. But ultimately, maybe the hardest decision we had to make on this project was cutting that out of the equation. We really wanted to make that work, but in the end, it just didn't work well in the dark. And we wanted it to be dark so you could really see these visuals. So ultimately, we cut that. It was, I guess, emotionally the hardest decision, but logically the easiest decision. And it was a really fun thing. It was fun to put together. I really enjoyed working with Alex and Anderson. They were all very accommodating and very happy to bounce ideas off. So I think we had a great dynamic, and David, of course, helped a lot, and so did tons of other people. So we had a lot of fun. And yeah, I think I've kind of covered the general idea, but if anyone has any questions, I'd be happy to answer them.
Yeah, we'll do questions at the end.
Absolutely.
So, yes. So thank you, Hunter, very
Thank you
much.
so much, David.
Yeah. So you can see this first project, very abstract sort of art installation, fun interaction from Team Mosh Pit. Our second team was Team Solarpunk with Kyler and Tyler. Neither of them were able to make it this morning, unfortunately. Thanks, Siri. So they actually created, they used the cyclorama and the HDLA. They created an original environment, a world in Unreal Engine. And then they did a fly-through of it on the cyclorama. So it was not an interactive piece. It was more of a sort of cinematic exploration. And they spent most of the 2 weeks holed up in Experience Studio, creating their Unreal environment, and then occasionally testing it here in the cyclorama. But I'll go ahead and let this play out for you so you can check it out. I apologize for the audio quality. This is from the camera microphone that recorded everything. So for those of you who might be unfamiliar with computer-generated graphics or things like that, this was all real-time rendered, and what that means is you don't need to do a traditional thing where maybe like for Toy Story, they animate all this stuff, they add all these textures, and they have to send it to a super powerful computer that takes weeks or months to render out a few seconds of final video that you're going to see in the movie. This is all done real-time rendering. I mean, real-time. It probably took a few minutes, or orders of magnitude less time to create to render out the final version than it would from traditional sort of computer animation methods. So it's a really lovely to see students pushing the boundaries of this sort of thing, especially in such a short amount of time. They only did this in 2 weeks. Granted, they used a lot of fun plugins and tools and some pre-made assets and things like that, but they created this entire world and soundscape from scratch. And so our third team was Team Space Jam with Atlas, Suraj, and Zhang. And Atlas is here, and she's going to talk about things. And she brought the super cool sphere.
I brought the sphere. Hi, so as David mentioned, my name is Atlas Vernier. I am a senior in Industrial and Systems Engineering and French, dual degrees. I was working with Suraj Bhatia, who's a thesis student in architecture, and Zhang Li, who is in creative technologies. So our idea for this, it all starts with this little glowing orb that I have in my hands. And this was motion tracked in order to determine your location. And based on this, you were able to explore kind of a virtual environment and a virtual soundscape that was themed around the solar system. So we had dedicated spaces for all the different orbits. And based on your location within those orbits, of the systems that David mentioned, we did use all of them. Go big or go home. And so based on your location, it would auto-generate music. And so because it was live generated in real time, and it was randomly arpeggiated, no matter how long you stayed in an orbit or every time you re-entered a planet's orbit, you would always hear something new. You would always have new music. And so every planet had its own instrumentation, its own musical notation, its own key. And so you can see Phyllis kind of exploring through. So we have the cyclorama with the star field in the back. You can see the floor light up. It all starts with this, which was controlled through Qualisys. We then linked that into Max. Let me see if I can remember how we did this, which processed the data and then sent out signals accordingly to generate the music, connected that to logic for the arpeggiation, connected that to Touch Designer for the floor projection, which just made a really cool virtual solar system.
Yeah, you all really you bit off a lot, but you pulled it off. So thank you so much, Alice. This is amazing. I'll let this play for a second. You can see how much Phyllis enjoyed doing this. And we'll let a little bit of Eric playing around with this because he really enjoyed playing with it too. Not only were these projects really successful, and it was lovely to see the interaction and the group dynamics that happened and how much fun everyone had. It was a joy for me to have all these folks in the class. But it was really fun having everybody see these projects at the end of the 2 weeks. And here's just a few little moments of joy that were captured during the presentations. And I thought those were really, really nice. But you want to go to the next slide, maybe? Okay. Just a special thanks to a few people who without, if I forgot you, I'm sorry, but who without this would not have happened. Brandon, Gustavo, and Tanner for all their technical help with the students and getting systems running and everything like that. Ben, Holly, Aki, and Catherine for making this administratively work, because otherwise we would not have been able to do that. And I know that I was the one pushing to have this class, and so thank you all for helping to make this happen. And also thanks to the College of Architecture, Arts, and Design. And that's it, and we'll have some questions. We have a few minutes left to have questions.
What questions do we have? I'll hold on to the mic. I'll hold it.
Okay. Hi. I have a question from Hunter. Oh, okay.
I should be able to answer the question, though. If
Okay.
Yeah.
I was wondering which programming language did he use? He said it's a visual language, but it's like
Yeah.
you don't have to code.
It's called Touch Designer. So it's a node-based programming language, but it's, for creating audio and visual things. A lot of people use it for visualizations for live performance. You can also use it for 3D things and things like that. So there is a free non-commercial version that just throttles the resolution output, but it's otherwise pretty full featured. So I highly recommend checking it out if you're interested in that sort of thing.
Super cool, David. Every time you give a presentation, it's great. What did you observe about teaching a class like this, and what will you do different or the same next time?
Ooh, let me go away for half an hour and think about that. No, so teaching a class like this is, I would say, very different than teaching a traditional, lecture sort of class, where we do some intense workshop-y sort of example things of all the systems in the class to show what's possible. And then it's really, you decide what you're going to do very fast, form your groups, and then we're going to spend intense time on the systems and things that you learn how to do. So it was a lot of one-on-one time with the groups and the students, which I really like. I don't necessarily like standing up and pontificating about things. So that interaction, that personal interaction, and then the seeing what they create at the end is really great for me. What would I do differently? I don't know. So much of it is specific to the group of students that happen, or that happen to be in the class, as far as what systems they use and things like that. I might try and get more students and maybe more cross-representation at the university.
What would be a cap for
I feel like maybe 12 to 15 I could probably handle. We could handle in here. So no, it wasn't set. That was just how many signed up. We had 8. Yeah, and that was we had 3 groups, 2 groups of 3 and 1 group of 2. So it worked out really well.
David, I'd like to add to that question. So your students and you had amazing amount of things done in 2 weeks. If you had the 18 weeks, what would you put before it and after it? Or would you expand? Would you still say, hey, do this in 2 weeks and then add something else after it? Or
well, I don't think you could do these projects in 2 weeks of a traditional class. If it was 18 weeks of 4 hours a day, oh my gosh, you could make the most amazing immersive experience that you ever had. I've actually had this question from somebody about how you would take this class and do it on a traditional semester schedule. With this specific space, I don't think it would be possible just because of the scheduling constrictions that happen here during the semester. I think it would be possible if there were a dedicated space for the class or dedicated time for the class. It would definitely be lots of revisiting, more of like a curly Q sort of loop rather than this super intense, laser focused kind of freight train sort of workshop that we had, which is you're learning this and then you're using it immediately, rather than, oh, we learned this 3 weeks ago and now you're going to try and implement it and kind of keep going that way. So it would be interesting to see how the dynamic between the students was different, and also how the projects would change if they were slower and over a longer period of time.
So I was just wondering, because it's so interdisciplinary, do you spend some time to teach affect? Because I feel like there's so much affective pieces in here. I'm coming from a background in engineering where, I spend a lot of time to teach affect, and because students are like, no, I just want to make a cool robot, right? And so how do you deal with that? Because since you have people coming in with so many disciplines.
This time we're very lucky with the groups really meshed well, and so some students had strengths in the technical things, technical disciplines, and some students really had the strength in bringing that affect and sentiment to the projects. It is something that's hard to teach, and I think that's one of the reasons why we like to do this class, is bringing those students together where you have creative disciplines, or traditionally creative visual arts, performing arts disciplines, working with engineers or working with life sciences. Like, I wish we would have gotten some life science students in here. We got to throw some flyers across the other side of campus for them. But yeah, this one was really sort of serendipitous, but I could see how that might be challenging, especially if you get a lot more engineering or computer science backgrounds. It's a great question.
I have a question for Atlas and any other students that are here. Was there anything in terms of takeaways that really surprised you, or that you're really joyful about that you weren't expecting?
Honestly, so I came into this, full disclosure, I came in really nervous about working with other people. I think every engineer has at least once in their life had just a really bad group project. And so on day one, I was like, oh God. But it turned out to be really lucky working with Suraj and Zhang. And to answer kind of your question, I came into this with a very technical approach. I mean, engineering, I was a roboticist before I was anything else. And so having the more artistic side and architecture, which is kind of a balance between the creative and the technical, having that collaboration worked really, really well, and that was what I enjoyed a lot.
Well, we're at time. Thank you for all these great questions. Thank you, David, for your work, for making the class happen, and for all of those who were involved. What a fun experience. There's so much joy and discovery. Maybe it came through, but I had a great time at their show at the end of the class. I want to thank you all for being here again this week. Next week we'll be back in the CID. If you're watching online, make sure you hit subscribe so you'll see more. We'll be back in the CID next week, and we'll be talking about ChatGPT and creativity. And more words? Is that good? Okay, good. So we'll be there next week with more donuts. If you haven't signed in, make sure you do. And I think I got everybody who had signed up for PDN, but check in with me if you need that. Have a great weekend, and we'll see you again soon. Thanks, y'all.
Thank you all so much.